title, of course, is the electric throttle for our energy transition, with specific focusing on community microgrids. Now, there's the old way and the new way. We're talking the new way. Now, a typical microgrid consists of, multiple parts. And you're going to start over here on the right-hand side. You can see generation that is coming from gas turbines, combined heat and power. And then the loads can be EV chargers, multiple homes or one home, as well as industrial buildings, commercial, and as well as hospitals and emergency services, etc. The point is that a microgrid is not one design. It can be one or some or all of the above. And of course, one common element is a connection to the grid. And typically these parts are located in one geographic area where we can call it a community. Now, when we take a look at aggregating, many of these, that we then call this a community microgrid. And if you take aggregating many of them to get a equivalent power production greater than 3 megawatts, we call that a virtual power plant. And of course, these are ways to restructure the main grid with distributed energy and storage. 5 major technologies of a typical community microgrid are, of course, renewable generation, as well as energy efficiency. So that includes any passive techniques like adding more insulation and closing up windows that leak, etc. And the use of heat pumps is very big and quite important, because most of the energy used in the home, some 81%, is in fact used up in heating and cooling the house. Therefore, one has to take a look at the use of heat pumps, either capturing from the atmosphere or geothermal. Storage, of course, is a necessary technology, and that typically means batteries, but there's other ways to store electricity as well. And of course, storing heat in the ground is one thing which I do as well, which makes the ground source heat pump very, very useful. Electric vehicles are, in fact, an integral part of microgrids, and I'll be talking about that, and the digital command and control systems using blockchain, AI, and IoT, of course, are all part of that. But one of the things that's really important is that all the major stakeholders are winners, and that means the residents, the people who own it, and of course the utility itself. Just want to use some pictures because they're always so much better than words, and we'll fly through these rapidly. But here's a microgrid in Australia with an awful lot of solar on the top, and you can see off on the right they've got some batteries. And here's a community microgrid in the Netherlands. As you can see, everyone in this community has got some solar on their roof, and they've all got a battery. And they're all interconnected, and they work together. And here's one in the U.S. with his multiple buildings in a community microgrid, and you can see multiple buildings there, all with solar on the roof. Now, they've gone quite a way in the US. Here you can see an entire bus fleet that is electric buses, and on the second floor you can see these are EV charging stations, and above that is a canopy with generating solar, and that's kind of what it looks like looking from the top down. And although this is a drawing, but you can see the buses being charged here, and you see the ramp of EVs going up to join the charging station, and they in fact use any excess to generate hydrogen, which they then sell as well. Now, grids and microgrids, from 1950 to 2021, the North American electricity demand has grown 13 times in size, just enormous. And whereas they're still looking at further extension and growth. And so microgrids do, in fact, expand the utility grid size and ease congestion, because microgrids become part of the grid. To see what's happening here in North America, the continent is broken into three main grids, East, West, and Texas. And of course, this stretches up into Canada, and we're part of that, and as well as down into Mexico as part of the North American grid. Each state or province or jurisdiction has its own independent system operator. Here's what Ontario's independent electricity system operator, called the IESO, what their command and control center looks like. And this is one of several stations which is looking after our grid 24/7. Now, one thing that's kind of interesting is to understand the terminology, and you'll hear me talk, and the people in the industry talk about transmission towers versus distribution towers. And transmission towers are the high voltage, big towers carrying lots from the centralized generating station to commercial and residential. But en route, they're going through a number of transformers where the voltage is dropped, and typically these are wooden poles. And for those who are interested in single line electrical drawings, that's a fairly reasonable rendition. Now, what's happening here, looking at Ontario, I mean, substation transformers, 3,000, but distribution transformers, over 1 million of those. Power poles, wooden poles, almost 11 million. Huge area coverage, What could possibly go wrong with this 100-year-old system? Right? And this was the ice storm of '98, and which I'm sure many of you have experienced. And here was the transformer, or the Maryville transformer station, with the tornado in September of 2018. And of course, our Directo of last May, or May 22, and just down Maryville Road. I just had to include this one because look at the ice load on the line here. The lines are actually touching the ground. Why they haven't failed, I have no idea. But does that ever paint decentralization just gets rid of all those problems. Now, I want to talk quickly about my microgrid, and I've laid this out in a way, hopefully, that makes it easy to understand. If I said here, demand energy is thermal, 82%. I said 81 earlier, 82. Anyway, it's big compared to electricity. I've lined these things up in terms of demand, storage, sources, and sinks, with identifying the thermal in a different color than the electricity. demands, of course, are lighting, cooking, computing, all the appliances and things in your house. Your electric car is a load, and space heating and cooling from the geothermal side is a load, as well as hot water. Whereas in storage, I have home batteries, Tesla batteries, power walls, and I do ground storage of heat as well. Sources and sinks, of course, are solar PV panels. We have a connection to the grid, which on the X's mean that's just a switch that says I can island. I can turn the grid off and be standalone. I have put in an additional heater that allows me to take excess electrical energy that I have generated due to solar and dump it into my geothermal system, into the heat pump, and store it in the ground. Now, after I've just got 5 years worth of performance of looking at supply versus demand, and yes, I'm over designed here, in that my demand looks fairly linear. I'm surprised it's that linear, whereas the supply, you can see it flattens out in the winter, and it picks up and produces a lot in the summer, and so that's what the irregular shaped and nonlinearities are. And of course, I call the gap between them the return on investment, and I'll talk more about that. Geothermal, you're standing on a vast amount of energy, and of course, this is not to scale, but it's a nice diagram that kind of shows that the deeper you go, the hotter it gets, and the Earth's crust. And here's another nice example that shows the crust as something very thin, whereas by the time you get to the inner core, it's the same temperature as the temperature of the sun at 6,000 degrees C, and right in the core, it's much higher. Now, geothermal heat pumps come in two types, really, closed loop and open loop. And the closed loop, of course, are just coils put in the ground. Here's a closed loop. A coil is put in a river or a pond or lake. That's really the best thing to do, quite frankly. Other closed loops are a number of vertical drilled areas, and this requires the least amount of ground space. Open loop systems are literally you take water out of one well and extract heat from it and dump it into another well, and then that automatically transfers over through the ground, picking up heat on its way. Open loop systems, I don't particularly like. People have a lot of trouble with them because they pick up contaminants and other things which do not work well with a lot of mechanical pumps and things. This is my system that was going in, and you can see it's got a coil as the heat exchanger. The trench in the ground, it only went down about 8 feet and into laid clay. And I just draw your attention to the fact that the trench walls are vertical. It's not collapsing in. And that's one of the magical things about laid clay. It's called an aquitard. Water doesn't move through it very well at all, which is an advantage. Here's what my geothermal wall looks like, because I have two coils in the ground, and of course, when I was installing this, I added in a number of excess actuators and extra thermocouples and an additional heater and things. This is way more than what a commercial unit would do. I've got over here Raspberry Pi computer, and where I can play with the software and find out what's really going on. The community microgrids using geothermal, have been proposed that, look, once you've got it all dug up and you're putting in cable, electric, gas, storm sewer, water, those services, why don't you at the same time, put in, some geothermal, spacing every 20 feet and drill down 500 feet, and then cover the whole lot up, and then you can use that to heat and cool the homes. Now, solar, wind, and storage. Well, there's many natural and creative ways to generate and store energy. Of course, get them, the panels off the ground, always a good idea. And put them on roofs. Here's a Tesla solar roof in Hawaii. You might have heard of Tesla solar roof. They've had a number of problems getting that off and going. I think they're on version 3 of their design now, and they're always bullish, saying they're ready to go. Here's solar voltaic and hot water panels in a European microgrid. These are hot water, and of course these are solar PV hot water, and this is quite common in much of Europe these days. Just wanted to show some of the performance of what was happening on my system back in March of 23. It was a very good solar day. As you can see, over 24 hours here, that the sun rose, reached its maximum and dropped off again at sunset time. And that was my generation. There's my supply. In the meantime, this is what my demand was. And of course, it's quite different, totally different shape. And as you can see, in the wee hours of the morning, there's a base load that's going, and sump pumps and goodness knows what, all the refrigerator turning on and off, causing fluctuations. And here just before 6 o'clock, the hot water heater comes on because I've got it programmed to do that. And my EV started charging to get ready for departure at 8 o'clock. And that's the way I've got that programmed. And you can see a little bit of the activity that's going on around breakfast time. These are hot water heating events that are peaking up as well. Now, to bridge the gap between these two, I'm using the grid. I did not use the batteries. I'm just using the grid here as a battery, and so you can see here that this is from the grid, and below the axis is, of course, to the grid. And so it says that by the time the day was done, I had stored 12 kilowatt hours on the grid for use on another day. In Australia, there's lots of solar available, but batteries are very expensive. So what's happened is they're putting community batteries on telephone poles. I thought it was very creative, and then integrating. And this is the utility doing that, supplying the batteries, and they make virtual power plants out of a number of communities. Very good. Now, for those who aren't familiar, Tesla makes mega packs of batteries, and each one of these will fit into a shipping container, and there's lots of data here on the size and the amount of storage it'll do. Flywheels, of course, are another way to store energy, and some of them are pretty big, and they are used in some locations. Agrivoltaics is becoming very big, as people say we don't want to put solar farms on agricultural land. And so the answer is share it. Put the solar panels above some of the crops, and because the panels will run cooler, and so will the crops. They'll be cooler. They'll need less water, and this is working quite nicely. In the Netherlands here, you can see some agrivoltaics being built out, and you can see the agricultural farms here down beneath as they're adding more solar panels on top of it. And of course, you can see lots of wind in the background, or wind generation in the background as well. And here's the other one that says, well, just raise them up a little bit more and let the sheep and cattle and other animals roam underneath. And that provides shade as well for the animals from the intense heat. Now, vertical solar panels do exist, and there's a number of new designs that are under development as we talk. In China, they have floating solar farms, and that helps keep the water cool for the fish. And in Morocco, I thought this was very neat. Well, what a complex design for solar tracking. Now, this is out of LA. I don't know if anyone's driven through there, and you come out on the Arizona side, and my, there's acre and acre and acres. As far as the eye can see, there's windmills and solar. So it's big business. In Germany, of course, the concern is always how do you find the land? And of course, the Germans said, well, look, why don't we use the land beside roadways and put both solar and little windmills all along it, and that way we're not compromising any farmland. And in Massachusetts, this is an actual photograph of a service station or an energy station where there's a solar panel canopy and charging stations beneath, of course. And over here on the right, they've got a fairly large battery, and of course you can go in here and have breakfast or lunch and spend some money in the shops. Electric vehicles. Well, these are really quite amazing things. I do want to kick in some facts here, because there's a social cost due to greenhouse gases from internal combustion engines. And I got this from physics.org, and which is quite a reliable website. But their studies are showing that gasoline particles at the micron level, particle size of 2.5 micron, adds healthcare and other climate change impacts. But turn that into dollars means it's $3.8 per gallon, and diesel adds $4.8. Natural gas is twice the diesel, and coal is 4 times the diesel cost. And of course, the polluters do not pay this price. And whereas if you look at parts of Europe, in fact, they do try and tax gasoline and diesel much more than we do here. And they had this interesting number. It says EVs on average from an average grid, whatever that means, get the equivalent of 88 miles per gallon in emissions. They do acknowledge, and it is correct, that manufacturing EVs is in fact about 15% higher than internal combustion engine, but they say that after 18 months of driving, you break even. Now, destination chargers, this is being built out if we're going to really have EVs come to a major way of reducing greenhouse gases. But you've got to have them in your home, at work, when you're off shopping, hotels, restaurants, et cetera, et cetera. And this is just starting to be built out now. The whole idea being that you should have your vehicle plugged in when you're not moving. And that means ultimately that you need quite a few charging stations. And one estimate is 3 times as many charging stations as there are EVs. And of course, in my case, it's I have near zero EV emissions because I'm generating the power which is used for my mobility. And interesting factoid that I didn't realize, that 70 manufacturers of zero emissions buses are active in California right now. And California is taking off doing this in a major way. In China, by the way, they're well ahead of what's happening in North America with electrified buses. Here's a typical all-electric home, and it's got Powerwall batteries, 2 of them, level 2 charger, which is good for up to 19 kilowatts AC. And Tesla early in 22 ramped up production of these Powerwall batteries to about 6,500 per week. And so they're really getting distributed now. Here is a level 3 charging station for Tesla. It goes up to 250 kilowatts. And of course, when you get it up there, it's all DC, no longer AC. And of course, there's 40,000 Tesla power stations out there in North America now. And they do use Second Life lithium-ion batteries as a means to store energy for after hours, as it were, to charge other EVs. Underground parking lot for managed charging station. And vehicle to grid. Well, this is really important, and it certainly hasn't been implemented worldwide yet, but there's been quite a number of tests done on this, which means that if you have a compliant charging point, it means that you can provide power to the grid during their peak demand times, which is from 5 p.m. until 9 p.m. And the tests that were done in California were offering those people who participated $2 per delivered kilowatt hour. And you think, compare that to some utilities at a low rate at night of 2.5 cents. That's a tiny piece of little business that you can get out of the battery in your EV or your Powerwalls. And so I often look at an electric vehicle as a battery and a computer on wheels, which, just by the by, you can also use it to transport yourself and other things around, but that's its secondary use. But it is primarily a battery on wheels. And the design takes a look at it, and it sure looks like a skateboard. And there is the batteries and the wheels. And they literally have the motors at each end, and they literally just drop the body on top. And as of late, they're talking about 2 million mile batteries, which really means if you own one of these batteries, they don't lose performance until or down about 10% after you've driven the vehicle more than 2 million miles. Well, I mean, you got to put your battery in your in your will, because and pass it on to your children. Anyway, the vehicle will wear out and you have to change it. You don't have to change the battery. Here's of course, in California, a basic microgrid EV charging station, which is kind of interesting. Now, you'll see the term EVX, V2X, which means vehicle connected via bidirectional charging point, which it could be vehicle to home, vehicle to grid, vehicle to building, et cetera, et cetera. And it is in fact something, a technology that is coming, and it will be used to help supply power to the grid as the demand are changing. And I did make the point earlier that you need up to 3 times as many destination charge points as there are EVs. So it means that you can plug in and have two-way bi-directional energy management whenever the vehicle isn't moving. And recently there's been some tests and developments going on to wireless charging, which, you know, just like your cell phone, you put it down on a pad or you just in a parking lot spot and it'll charge up. Control systems, hardware and software. Well, of course, this is trading software, and there's really 4 types. You got the customer, which is typically the homeowner, and it's monitoring consumption and controls and on all operating systems, and it certainly is to the customer. You become very energy literate and aware of the situation. There'll be means to have credits for remote generation and efficiency, survival, and on all sorts of new things start coming up as the consumer becomes an integral part of the energy equation. Of course, we have installer software as well, which has to have the ability to debug and provide updates and check all interfaces and do the operational checks. The third type of software, trading software, of course, is the administrator, or the manager, the community microgrid, and who is looking at battery management, bidirectional flows, configurations and sales, etc., and the interaction with the grid utility. The fourth one of software packages are virtual power plant, which is typically commanded and controlled by the utility as well as an aggregator, which is a private sector company. But these 4 types of software, you know, enable peer-to-peer energy transactions, as microgrid trading platforms, to optimize energy consumption, reduce costs, and improve overall efficiency. And of course, these do use all the latest technologies, including blockchain and AI and energy as a service contracts, etc., as well as the ability to generate reports and graphs, etc., which people need to be able to make decisions in the future as to how they're going to operate their systems. Hardware interfacing, of course, has a number of challenges, because solar and wind, diesel gas generators, and they're produced by quite a number of people, and there doesn't seem to be any standard interfaces between them all. Often they're considered that they're going to be standalone and they don't have to interact with anyone. Of course, battery as well. They're have different software packages and hardware connections and what have you. But these sort of things have to be addressed, and they are starting to being addressed. Yeah, and EVs, of course, really need to come up with one type of connector, and there's been a fair amount of activity happening in North America, trying to get all suppliers of electric vehicles to adopt to the Tesla standard, and that seems to be moving ahead quite nicely. And of course, when we take a look at residential and high-rise towers, of course, there's each one of them has some form of interesting Internet of Things issues, security, elevators, of course, and any specialty considerations. Emergency measures, hardware, of course, hospital, fire departments, etc., as well as government centers. You know, they have unique requirements, and just how you interface with all their hardware concerns is another interesting challenge. Standards hardening and compliance with the utility and each other.
I see that now that I'm closer.
Thing and fire resistant, weather damage, etc., and as well as having some form of resistance to state actor cyber attacks, as well as vegetation and animals that get at things and cause havoc. Now, Section 6. This is the area where I say, okay, just stop burning, and because this is the frontier of the new climate economy, and these are rapidly expanding. Most people look at looking at a microgrid is all about money, and how they can save money. But I'm going to show you there are many benefits to microgrids which are not finance. They're in fact social. Of course, we'll start off with the costs at the stop. Of course, collecting sun and geothermal, it's there everywhere. All you have to do is get out there and collect it. And this means that the costs go down for the owners, the consumers, utilities, and all the stakeholders. It also means that governments don't have to subsidize you because you're not drawing energy from the grid. You're in fact generating your own. Now, it also protects the users from energy inflation, or at least the consumers from energy inflation, and I call it cost growth avoidance. You know, I look at the way the cost of energy is going up at the pump and at natural gas and electricity, and I just shrug and say, got nothing to do with me. And so I'm just totally avoiding that an inflationary pressure. And in fact, if in fact this was all taken into play, that studies have said, hey, it could be utilities could provide power at 50 to 75% less than what you're paying now. And but it means optimizing the use of available local resources. But this sort of thing is coming. And of course, expand social and wealth equity. Well, you know, there's this reality when you have grid outages that you do end up worried about your refrigerator and you have food and water issues. If your well pump isn't going, and of course there's other ways to get water purity, and what I'm doing as well is I'm adding ultraviolet band C to manage viruses or kill viruses, bacteria, molds in my home, and I put that in as part of my microgrid. supply reliability, it greatly increases reliability because it is much more reliable than the grid itself, which is a bunch of old wooden poles which can get blown over with all the weather events. And we also have smoke and other issues which are happening, but in a microgrid you can make accommodations for that. And we know that atmospheric, climatic, and geopolitical catastrophes are a certainty to increase. So reliability, big issue. Improves social resilience and liberation from the fragile grid. Well, I talked a little bit about that already, but there are all these instabilities which, cause fear, frustration, inconvenience, heat stress, damage. There's so many things, and could even cause death by having a safer shared resource infrastructure. And so I put resilience and liberation together there as two very big advantages. Time-shifting energy awareness to deliver on the growing expectation of residents, because you need a means to encourage people to be innovative, and with AI driven insight and methods to actually reduce their energy costs and improve and provide livelihood opportunities. Provide an opportunity for communities to generate their own distributed energy technology and sell the excess into virtual power plants using blockchain, of course. Allow communities to manage their own energy savings, consumption, and reinvestment of profits. And again, we're back to freedom from the centralized eco-denialism, cheating, deception, distraction, single dimension, dollar political thinking. And I'm talking primarily of the Ford government in Ontario, that the only thing that matters is money. Promote community pride and prestige in their energy democracy. And in a community, this then, if they own it, they got skin in the game, and they're happy to talk about economic development and what their latest methods are in reduction of consumption. And the 10th one I've got here is encourage empowerment of the communities and independence through innovation, as well as provide resident technical and administrative training. Do local product development. Every neighborhood or community has something that's unique, opportunity for people to get creative and what they can do. And of course, avoid the fossil fuel generators, the noise and smell we're all aware of, and that's not necessary. Energy arbitrage, to go off and buy low, sell high, and that in fact happens if you have battery and you can time shift your energy charge time at the low rates and even sell it at the high rates back into the grid. That's a big advantage. That's a more financial one, and of course the utilities are happy as well, because this provides stability in the fact that voltage, frequency, and phase is what they use to balance the grid at the community level and even down to the household level. And you can either be with a battery, you can either be a grid follower or leading the voltage frequency phase. And that's what the big batteries are that a lot of like the ISO is putting in, taking the noisy signal that comes from a lot of microgrids and putting them into a battery, into DC, then turning the DC back into AC, but having very tight control on frequency and phase as well as voltage. That's the difference between leading and following. And of course, geostrategic utility on microgrids can also be something that the utilities can undertake because they would be more interested in having it some other place than where your residence is. And of course, this then provides the ability for them to avoid utility repair costs. And they're very much aware of this and are on board. Well, as we're also looking at community microgrid provides, opportunities to do peer-to-peer trading with other communities and ultimately to make a community of communities. And if you stretch that far enough, you can say, if you have a community of communities, pretty soon you got yourself an entire city, and all trading without any need to connect to the transformer station in Toronto or Quebec or wherever. And of course, the there is some real engineering required to make sure that the grid utilities are involved, because they know where all the potholes are, as it were, within the grid and the problems. But my discussions with any of them, they're fully on board. And in fact, we'll hear some of that on tomorrow on the KCOR presentation. We're having someone from the city talk to us about what they see as their pathway forward in energy for the city. And the big one is, as far as I'm concerned, is stop the destruction of nature. Not just reduce pollution, but encourage compatibility with a thriving ecosphere. Do no harm, and let the natural processes go. And in fact, other than the manufacturing side, once you have geothermal and solar and wind, you're not doing any more damage to the environment. Operational versatility, and I'm a big pursuer of this concept of prepare to survive. Start building your microgrid now. Don't wait till the disaster or after the disaster. You do the preparation prior to the disaster, and that's an advantage of a microgrid. Reducing greenhouse gas emissions, yes, of course. You're not burning anything, so you are getting mitigation as well as adaptation to changing conditions. They improve shelter security, of course. When the power goes out, your active alarms and cameras and doorbells and what have you, they don't work either. But with a microgrid, you do have those that continue to operate, and you do still have the ability to have digital security in your premises. Another, number 18, is to the EV vehicle to grid. I've talked about that as well, and use of blockchain to accelerate microgrid proliferation. Isolate and protect, number 19, from aging utility infrastructure, and I showed you some of the damages and that result, and the ability to island, and you can choose when you want to become visible to the utility, and that's your call. Help Canadians prepare for growing catastrophe exposure, because we know that we're going to be subjected to more extreme climate disruptions. And I've taken the position that I'm going to disrupt whatever normal was and operate continuously in a low stress emergency mode, which means that I'm sitting here waiting for a disaster to come, and I'm ready to go. I know exactly what to do. So I'm not going to be caught short when that happens. Now, the 21st, this is really the big one. It improves life meaning, peace of mind, quality of life, well-being, and which really addresses the Maslow's hierarchy of needs, including mental stress, loneliness, isolation, values, and I went and pulled this out and said, how can microgrids really assist in all this? Well, look, basic needs: food, water, warmth, rest. Yes, security. We've talked about all these. Loneliness, relationships, friends, esteem need. In fact, all of these, are social benefits. Don't see any money here at all. And they're being provided by microgrids, community microgrids. And I took a look at the indigenous model, which, as well as the Mennonite model, and they look at these as well. It's slightly differently, mind you, but they still include, the basics and being part of a community, spirituality, life purpose, belonging, and relationships. So the big takeaway I hope you get from all this is that community microgrids have tremendous social value. They're not just Doug Ford money makers. And that is the end of the old way.